Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudewa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 4. It says methyl benzoate is a compound used in the manufacture of perfumes. It is found that a 5.325 gram sample of methyl benzoate, which is the whole compound, contains 3.758 gram of carbon, 0.316 gram of hydrogen, and 1.251 gram of oxygen. So we know when it comes to the empirical formula, we are only concerned about the masses of each element, right? So the 5.325 gram here is of the whole compound, meaning if you add this number, that number, and this number here, you are supposed to get that 5.325 gram. Right. So 4.1.1 says define the term mole. So quickly on that one, what is a mole? We say mole is the SI unit for the amount of substance. Right. And then we go to 4.1.2. It says determine the empirical formula of the methyl benzoate. So we know that the first step to do is to calculate the number of moles of each element. So we have mass over the molar mass. The mass for carbon is 3.758. Then the molar mass from the periodic table is 12. And then if you punch all of that into your calculator, you get 0.3131 mole, right? And then we have hydrogen. So number of moles of hydrogen is mass over the molar mass, which will give us 0.316 divided by 1, which is 0.316 mole, right? Then lastly, we have the number of moles of the oxygen. So mass over the molar mass. Our mass is 1.251. Then divide that by 16. So this will give us 0.078 mole, right? Now that we have the number of moles of each element, the second step is to divide by the smallest number of moles. So we know that the smallest number of moles is that one there. So to find the ratio of atoms of carbon, we have to say 0.3131 divided by 0.078. To find the ratio of the hydrogen, 0.316 also divided by 0.078, and then oxygen 0.078 over 0.078, right? Then when we punch that into our calculator, we get 4, obviously rounded off to the nearest whole number, and then if in here 4, and then this one is obviously 1. So then our empirical formula is supposed to look like this. So is that empirical? Hashtag I'm not an English teacher. Then empirical formula is C4H4 and then O, right? So that becomes our empirical formula there. Okay, nice. Then for 4.1.3, so they were supposed to say 4.1.3 here. They're saying if the molar mass of methyl benzoate is 136 gram per mole. So let's just erase this one. And then let's just keep the empirical formula. They're saying the molar mass is now 136 grams per mole. What is its molecular formula, right? So in order to determine the molecular formula, the first thing that we have to do is find the molar mass of the empirical formula. So we have 4 carbons. So that will make 4 multiplied by 12. And then we have 4 hydrogens, that will be 4 multiplied by 1. And then 1 oxygen, that is just 16. So when we punch all of that into our calculator, we get 68 grams per mole. So what we are trying to do here is find the number that we should multiply with. So the multiplier, so it's 136 divided by the 68, and then we get 2, right? So the 2 here, we are supposed to multiply the empirical formula with in order to get the molecular formula. So molecular formula will be like this. So we'll say we have 4 carbon atoms. If we multiply them by 2, we'll have 8. We have 4 hydrogen atoms. If we multiply them by 2, we have 8. We have only 1 oxygen atom. If we multiply it by 2, we have 2 there. So that means our molecular formula is now C8H8O2. So for 2 marks, that's all you are supposed to do. Find the molar mass of the empirical formula, divide to the given molar mass, and then find the multiplier, and there you go. Voila. Okay, so let's proceed now. That's not all. The question still continues. Okay. So we have 4.2. It says a sample of sodium carbonate was reacted with dilute hydrochloric acid in a closed container according to the following equation. So as we can see the equation there. And then the carbon dioxide gas produced was collected at STP. Now note, whenever we see the keyword STP, we know that this relates to the formula N is equals to V over Vm. I always made it a point that every time you see STP, standard temperature and pressure, you have to remember that the formula that we have to use is that one there. So the Vm obviously becomes the 22.4, right? And occupied a volume of 0.336 dm cube. So this is the given volume, which should go in here. Then the Vm is the constant, which is 22.4. 4.2.1 says state Avogadro's law. What is Avogadro's law? So quickly on that one, we say Avogadro's law states that 1 mole of any gas occupies the same volume at the same temperature and pressure, right? So note that that's how we define it. So make sure that if you were not aware of it, you quickly note it down. Okay, so now let's go to 4.2.2. Says calculate the number of moles of carbon dioxide produced for 3 marks. Now a 3-mark question, we know its formula, substitution, and the correct answer. So we always say that we should not lose a 3-mark question. Then we have already identified the formula that we should use. It's N is equals to V over Vm. The volume we've been given 0.336. Then our molar gas volume is the 22.4. So even if you check on your data sheet, you will see it's written as molar gas volume. And then if you punch that into your calculator, you are supposed to have 0.015 mole. So I'm just going to round off to 3 decimal places. Right. So that's your solution right there. And then 4.2.3 says calculate the number of carbon dioxide molecules. Note this, guys, it is very important to note that number of molecules and number of moles is not the same thing. The number of moles is that small n, but the number of molecules or the number of particles is the big N here. So when you get to use this formula that goes N is equals to N over Na. So this is what we are supposed to use for 4.2.3. This big N here, that's the number of molecules, right? So it is just the product of the number of moles multiplied by the Avogadro's constant. So if you can rearrange, this becomes N multiplied by Na, right? So the number of moles is 0.015 as you have determined in the previous question, but the Avogadro's constant is also given in your data sheet, which is 6.02 times 10 to the exponent of 23. So you don't have to memorize this one. It's given in your data sheet. Right. So when you multiply that, it gives you 9.03 times 10 to the exponent of 21. And you are supposed to write molecules. So this, in a way, kind of becomes your SI unit. So they ask you to calculate the number of molecules. Therefore, after finding the answer, you will say molecules, right? So for 2 marks, that's all you were supposed to do. Take your number of moles and multiply by the Avogadro's constant. And then there you go. Right. So nice. We are done with that one. So the one thing that you learned is that number of moles and number of molecules is not the same. Then 4.2.3 says calculate the mass of sodium chloride formed in this reaction. The mass of what? Sodium chloride. Which one is sodium chloride? Sodium chloride is NaCl. right? And then we have already determined the number of moles of carbon dioxide. Now, we always say that stoichiometry is not straightforward. So this is the case. We have calculated carbon dioxide, the number of moles. But if we want to calculate the mass of this, we need to compare the ratios so that we find the number of moles of the sodium chloride. So we can say, what is the ratio of sodium chloride to the carbon dioxide? And then from our coefficients, this is where we get the ratios. So we'll say it's 2:1, right? But then what is the number of moles of the sodium chloride? We don't have. That's what we are looking for. We have already calculated the number of moles of carbon dioxide in 4.2.2, which was 0.015. Then if we cross multiply this, we are supposed to get the number of moles required for the NaCl. So that's X. Then cross multiply here, we can get 0.03 mole, right? So we are saying for every 0.015 mole that is produced, there will be 0.03 mole that is produced of the NaCl, right? So the ratio is 1:2. Okay, so now that we have the number of moles, we have to remember that we are not looking for the number of moles. We are looking for the mass. So we still need to go further here. So this would probably get you a mark, just only 1 mark. And then for 4 marks, we still have 3 marks remaining. So we'll say mass. And then of sodium chloride, this will be the number of moles multiplied by the molar mass. Now we will use this number of moles because we have already calculated now. And then the molar mass is 58.5. So if you use your periodic table, you say 23 plus 35.5, you are supposed to get that 58.5 grams per mole. So that's where we take it. Then when you multiply this 2 here, you are then supposed to have 1.76 gram. So rounded off to 2 decimal places. It was saying 1.755. Then to 2 decimal places, it's just 1.76 gram. Okay. Then that's how you were supposed to calculate that. Then this one here would give you the rest of the 3 marks. So whenever you are writing, you need to know where your marks are, right? You need to know what is it that you're going to get marks on. Okay, so now we have 4.2.5 says define concentration in weights. What is concentration? We say concentration is the amount of substance dissolved per unit volume of solution, right? So that's just how you define concentration for 2 marks. Then 4.2.3, if the concentration of the hydrochloric acid is 0.10 mole per dm cube, what is the minimum volume of hydrochloric acid needed for the reaction to run to completion, right? So let's check that one. We are given that the concentration of hydrochloric acid is 0.10 mole. What is the minimum volume of hydrochloric acid? So they want the volume of the same hydrochloric acid needed for the reaction to run to completion. So this means this time around, we're going to say we have already calculated the number of moles of carbon dioxide. Now it's time to compare it to the hydrochloric acid that we are looking for. So the one thing that you have to learn here, once you are able to determine the number of moles of only just one substance, that means you can use that substance to get the number of moles of the other substances simply just by using coefficient ratios, right? I hope that makes sense. Your only duty is to get the number of moles of only one substance. And then to get the number of moles of the other substances, you just simply use coefficient ratios. If we want the number of moles of the H2O, we'll just compare the coefficient ratios. It's 1:1. That means it would have the same number of moles. We want the number of moles of this one here. We just compare the ratios 1:1. That means they would have the same number of moles. This to that, that means the sodium chloride has twice the number of moles. This to that, that means hydrochloric acid has twice the number of moles of carbon dioxide. Right. Then again, we're going to say the ratio of carbon dioxide to the ratio of hydrochloric acid. That's 1:2. So if carbon dioxide has 0.015, then what is the ratio? What is the number of moles of hydrochloric acid? It needs to be twice. Then when we cross multiply, that's 0.03 mole, which is twice this. Right. And then remember, we are not looking for the number of moles. We are looking for the volume. But then now that we have the number of mole, we know that we have concentration. We are looking for the volume, and then we have number of moles. Then obviously we can see which formula to use here. Again, it's a 4-mark question. So doing this will only give us a mark. And then the rest of the 3 mark is having to write the correct formula to use. C is equals to N over V. And then our concentration is 0.10. And then number of moles is 0.03, and then over V. Now, obviously, make V the subject of the formula. That's 0.03 divided by 0.10, and then our volume is 0.3 dm cube, right? And then there we go. We have the 3 marks, right? So formula substitution into the correct formula, and then the correct answer with the correct SI unit. Always remember that. Okay, so let's proceed. We're still not done. It's a very, very long question. You see, I'm relaxed. Then, okay, 4.3 says 50 grams of magnesium carbonate is added to 500 centimeter cube. Remember, every time you see your volume given in centimeter cube, the one thing that you immediately have to do is convert it to dm cube by simply dividing by 1000, right? When you divide by 1000, now you have 0.5 dm cube with a concentration of 0.75 mole per dm cube. The equation for the reaction is given below. The carbon dioxide gas is collected at STP. Again, we have that keyword, standard temperature and pressure. Now, 4.3.1 says, what are the standard conditions used when conducting an experiment at STP? So STP stands for standard temperature and pressure. So they just want to know what's that standard temperature, what's that standard pressure. So this is what you always have to say when it comes to that question. So we must always have a temperature of 0 degrees Celsius or 273 kelvins, which is equivalent to the 0 degrees Celsius. Then we must always have a pressure of 101.3 kilopascals, which is a atmospheric pressure, which is equivalent to the 101.3 kilopascals, right? Okay, so we have now 4.3.2 says determine which reactant is the limiting reactant, right? So, okay, when it comes to that, we know what to do. Every time we are determining the limiting reactant, we know that the first thing to do is to calculate the number of moles of each compound, right? So we have 50 grams of magnesium carbonate. So the magnesium carbonate is this one here. We are given the mass. So obviously to calculate the number of moles, we have to go N. So let me indicate the number of moles of which I'm calculating. Number of moles of magnesium carbonate. So it's mass over the molar mass. We are given 50 grams, then divided by the molar mass. Our molar mass is, if you add all that, it's 84. So your magnesium is 24, then plus 12 plus 3 times 16. It's going to give you 84. And then we have 0.593 mole, right? And then we still need to calculate the number of moles of the hydrochloric acid. So we'll say number of moles of HCl, right? But this time around, we have to note, we are given the volume and concentration. That means we can't use this formula. What's the other formula we can use to calculate the number of moles if we are given volume and concentration? It is obviously C is equals to N over V, right? Which we can rearrange to form C multiplied by V. So note, it is not always that you will use this formula. Then this is 0.75 multiplied by 0.5, right? The volume. And then we punch that into our calculator, that's 0.375 mole. Okay, so now we have the number of moles of the hydrochloric acid and then also of the magnesium carbonate. Note that in calculating this, we have never involved the 2 anywhere. right? So it's just simply number of moles. We are not supposed to multiply this by 2 or what so not. Then we go to step number 2. So these are the available. Always, I said, note that the ones that you'll calculate first are the available number of moles. So this is what we have available for both the magnesium carbonate and the hydrochloric acid. Now it's time for us to compare. In comparison, I always propose the method to you to make the second one here the reference, right? So this one here will be your reference compound, right? So this will be your reference compound. And then in that case, that means you'll be saying what amount of the hydrochloric acid needs to react with all of the magnesium carbonate. And then we go back here. We look at the ratio. The ratio is 1:2. So that's 1:2. What are the available number of moles of magnesium carbonate? It's 0.593. And then we put our X here because this is the reference. What we are trying to get is how much of the hydrochloric acid is actually required to react all of the magnesium carbonate. Then when we cross multiply here, we get X is equals to 1.186 mole. So we get that we actually need 1.186 mole of the hydrochloric acid to react with all of the magnesium carbonate. But then let's go back here. Do we have that available from the hydrochloric acid? We can see that no, because hydrochloric acid is only 0.375. But then we require more than what is available. So we know that every time the number of moles available is less than the number of moles required, we say that particular substance is limiting. So that means substance is the limiting reagent. Right. So because now we require more than what is available, that means our hydrochloric acid here will be the limiting reagent. It will be the substance that will be used up first in a chemical reaction, or that will be used up completely. Right. So that means, in other words, we can then conclude, therefore, hydrochloric acid is the limiting reagent. Why is it so? Because the number of available moles, the number of moles available is actually less than the number of moles that are required to react all of the magnesium carbonate. So I hope that makes sense. Okay, now let's proceed to 4.3.3. We have, if the percentage yield of the experiment is 85%, calculate the volume of carbon dioxide collected at the end of the experiment at STP, right? So the percentage yield is 85%. Now they say calculate the volume of what? Carbon dioxide. Let's go. Carbon dioxide. So this is all about having to calculate the percentage yield of the carbon dioxide, right? So we already have determined that our hydrochloric acid here is the limiting reagent. Now you will remember that I said once you have discovered that you have the limiting reagent, then the next thing to do is to find the theoretical yield. Then your theoretical yield will lead you to percentage yield. So you always use the limiting reagent, which is why every time you will see the question about the limiting reagent comes first before they ask you about the percentage yield, because you'll have to use the information of the limiting reagent in order to find more about the percentage yield or the theoretical yield. Right. So that means now comparing the hydrochloric acid to the carbon dioxide, we will say the ratio is what? 2:1. But then remember, we already have the number of moles of hydrochloric acid available. You have to use the ones that are available, right? So it's 0.375, and then here we have X. So obviously, having to calculate here, we need to cross multiply 2X, 0.375, divide both sides by 2, and then our X value becomes 0.1875 mole. Right. Now in this case, remember, STP. So whenever we see STP, we know the formula that we have to use is N is equals to V over Vm. So what are we looking for? The volume, right? And then our number of moles is 0.1875. And then we are looking for V, but then the Vm, the molar gas volume, remember, it is 22.4, right? And then when we cross multiply this, our volume needs to be what? So it is 4.2 dm cube. So this would be what we call the theoretical yield. Right, so this would be the maximum volume produced. So this would be the maximum volume. So this would be the theoretical yield. But then remember, they said the percentage yield is 85%. So that means actually what was produced is 85%. We were expecting 4.2 dm cube, which would be representing 100%. But then what was produced is 85% of this. So in order to get the volume that was actually produced, we need to calculate 85% of the 4.2, because the 4.2 here represents the maximum, which means it's the 100% of everything. So if we want to find 85%, we're just going to say 4.2 times 85 over 100. And then we actually find that the volume that was actually produced is 3.57 dm cube. So this here represents the 85%. And that's how you were supposed to go about answering that question. So as you can see, it was a pretty long question for 38 marks straight. So I've been telling you that stoichiometry has a lot of marks, both in grade 11 and grade 12. But if you can start mastering it from grade 11, then your grade 12 is just a walk in the park. So make sure that you are fully invested into studying this topic and knowing it. So don't just skip through it. Make sure that you give yourself time to master this topic. But then with all that being said, guys, please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.